Alright, hello and welcome. In this question, we are working through a stoichiometry problem combined with gas laws based on the use of sodium azide in airbags. This is exactly the kind of structured question where many students lose marks. Not because chemistry is hard, but because the thinking order is wrong. So pay close attention to how we organize each step. If you want to think like an examiner and answer questions like this with confidence, check the paper discussion class. Details are in the description. You can also learn theories efficiently through my masterclass series. Please visit academy.amila.guru for Amila Guru masterclasses. And if you don't know me, I'm Amila. I'm a chemistry educator and an author. And for years, I have helped GC A-level students not just learn chemistry, but learn how to score. With that in mind, let's get started. Fourth question of the third assignment. We need to calculate the volume of gas given off by complete decomposition of 60 grams of sodium azide. So let's first analyze the question. That means rough work. You don't need to write rough work. Let's analyze the question. So we need to calculate volume of nitrogen gas released. So can you suggest a method to calculate volume of nitrogen gas? We can use PV equals nRT, ideal gas equation, assuming nitrogen behaves like an ideal gas. Then it's clear that if we know the number of moles of nitrogen, temperature of the nitrogen and pressure of nitrogen, we can calculate volume of nitrogen. Temperature is given 310 degrees Celsius. That means we need to add 273 to make it kelvins. So it is 583 kelvins. Then pressure is given. It is 752 mercury millimeters. So if we know the number of moles of nitrogen, then we can calculate volume of nitrogen. So how to calculate number of moles of nitrogen? We need to know number of moles of sodium or number of moles of sodium azide. As the mass of sodium azide is given, we can use number of moles is mass over molar mass formula to calculate number of moles using mass of sodium azide. So that is the starting point. Calculation of number of moles of sodium azide. Okay, let's start the calculation. So first step, number of moles of sodium azide. Mass of sodium azide is 60 grams. What is the molar mass of sodium azide? Sodium 23, nitrogen 14, 3 nitrogen atoms are there, then 3 times 14, 42, 42 plus 23, 65 grams per mole. Always plug the values with the relevant units. Grams cancels out, per mole in the denominator, then it is moles in the numerator, then 60 over 65. We don't divide 60 over 65 using logarithms. What is the reason? This is not the final answer that we need. Therefore, we can keep this as a fraction. But we can divide by 5. So when we divide by 5, this is 12, this is 13. So we can write 12 over 13. Now we know the number of moles of sodium azide. The balanced chemical equation for the decomposition of sodium azide is given. Therefore, we can use the stoichiometry to calculate number of moles of nitrogen released or produced. Number of moles of nitrogen produced or released. In the question, it is given that complete decomposition can be assumed. Therefore, when 12 over 13 moles of sodium azide decomposed, what is the stoichiometry? 2 to 3. That means we need to divide this value by 2 and multiply by 3. Then when we divide 12 by 2, it is 6. So 6 times 3, 18. So 18 over 13 moles. Now we know number of moles of nitrogen, number of moles of this is number of moles of sodium azide. Using number of moles of sodium azide, we have calculated number of moles of nitrogen. Therefore, we can calculate volume of nitrogen, but this ideal gas equation can be used only for ideal gases. Therefore, first we need to assume nitrogen behaves like an ideal gas. Then we can use ideal gas equation. Volume of nitrogen gas released. So it's clear that volume is nRT over P. So number of moles is 18 over 13 moles, or 8.314 joules per mole per Kelvin. Temperature 310 degrees Celsius, that means 583 kelvins. Then pressure. Pressure is given in mercury millimeter, 752. So first we need to divide that by 760 to make it atmospheric pressures. Then we can multiply 1.013 times 10 to the power 5 to make that value pascals. So this is how you should plug the given values. (583) means 5.83 times 10 to the power 2. So we can divide 10 to the power 2. So all the values are substituted in SI units. Therefore, the volume is in its SI unit, that means cubic meters. Then 10 to the power 3 is in denominator. So in numerator, it is 10 to the power minus 3. So 18 times 8.314 times 5.83 times 760 over 13 times 752 times 1.013. So you need to check logarithms. Okay, first logarithm of 18. Logarithm of 18 is 1.2553. Then logarithm of 8.314, it is 0.9198. Then logarithm of 5.83, it is 0.7657. 7657. Then you need the logarithm of 760. It is 2.8808. So we need to multiply all those four values together so we can add the logarithm. 3 plus 8, 11 plus 7, 18 plus 8, 26. 2, 5 plus 9, 5 plus 2, 7, 7 plus 9, 16, 16 plus 5, 21. 2, 7, 8, 14, 22. 2, 4, 13, 20, 28. 2, 3, 5. So then logarithm of 13. Logarithm of 13 is 1.1139. Then logarithm of 752. 0.8762. Sorry, 2.8662. It is 752. It is 8762. Then logarithm of 1.013. It is 0.0056. So we need to add those three values. 11, 17. 1, 4, 10, 15. 1, 9, 9, 3. So we need to subtract 5.8316. We need to subtract 3.9957 from 5.8216. 16, 9, 0, 10, 5, 1, 2, 7, 8, 1. So we need to check the anti-logarithm of 1.8259. 1 means 10 to the power 1 times it is 6.697. 6.697, which means 66.97 times 10 to the power minus 3 cubic meters. In other words, it is 66.97 cubic decimeters. So that is the answer for this question. It seems that you take a lot of time to check logarithms, but that is the way that you should do this calculation. Therefore, practice using logarithms to do calculations like this. Don't use calculators to do calculations like this because calculators are not allowed during the advanced level examination. Therefore, please practice to use logarithms to do calculations like this. So when you have a question like this, first analyze the question. You can take about 30 to 40 seconds for the analysis. After analyzing the question, you can start the answering. Without analyzing, don't start the answering, because then you will not be able to get the correct answer. Check whether there are any errors. If there are any errors, please correct them. Then you can move to the next question. If you want to boost your chemistry marks, you can join our online paper discussion class. WhatsApp now to join. Don't wait. To get this question paper free of charge, WhatsApp now to 071 7191 626.